Okay, so continuing on with this problem, we've already done the first two steps. So if we go back up to our wonderful little heating curve, that is going from the negative 18 to 0 and 0 to 0. Now let's do 0 to 100. And again, we're in the horizontal, so we're using our MC delta T. So let's jump back down here. And we're going to do step 3, which again is Q equals MC delta T, where our M is still 112 because we haven't changed the amount of water we're dealing with. Our C is now different because we are dealing with liquid instead of ice, which is 4.184. Okay, and we are dealing with a change in temperature of 100 degrees Celsius. So again, final minus initial. The final is 100 minus 0 is 100. Okay, so Q is going to be equal to a mass of 112 times a specific heat capacity of 4.184 joules per gram degree Celsius times a change in temperature of 100 degrees Celsius. Okay, and we go through and do this math. Okay, and that's going to give us a Q of 3 sig figs. Again, we'll just consider this to be 100 point at the end of it because it is exactly 100. So 3 sig figs, which is 46,900 joules, are 46.9 kilojoules, however you want to do that. Okay, notice this is much higher than our first part. Okay, the amount of energy in the first one was only 4.21 kilojoules versus here we're dealing with 46.9 kilojoules. Why is it so much more? Two factors are going on here, same amount of water, but you're changing the temperature by 100 degrees versus 18 degrees, and the other thing is our specific heat capacity. For ice, it was only about 2. For liquid water, it's about 4, which means it takes twice as much energy to change it by 1 degree Celsius. So we do end up with a much higher change in temperature here. If we were only changing it by 18 degrees Celsius, we would be dealing with something around the 8 to 10 mark, because it would be twice the amount of energy required to change the temperature comparatively due to the specific heat capacity difference. Okay, so that's Q3. Going back up, let's look at our next step. Our next step is going from 100 to 100, which is step 4. So we're dealing our delta H of vaporization. So this is going to be basically the same thing as step 2 up here. Okay, so delta H of vaporization, which is going to be energy per mole. The nice thing, we've already calculated our moles. That hasn't changed, just like our mass hasn't changed. Let's go back up here and grab our delta H, though. It is 40.7. So 40.7 kilojoules is going to be equal to energy over our mole value, I believe was 6.22. Yep, 6.22. Or again, what we can do is set it up as 6.22 moles. And then we have 40.7 kilojoules per 1 mole. We can set it up either way. It's up to you how you want to do it. You're going to get the same number. So we have our 40.7 times 6.22. 3 proper sig figs again is going to give us an energy of 253 kilojoules. Okay, last step. We go back up to our phase change diagram. Whoop, our heating curve, sorry, not phase change diagram. We'll talk about phase change diagrams here shortly. Heating curve is going from 100 to 109, and again dealing with our MCAT. So scroll all the way down. Q equals MC delta T. M is still 112 grams. C is now, I believe, 1.996. Yep, 1.996. And that is joules per gram degree Celsius. And then, of course, our change in temperature here is only 9 degrees Celsius because we're going from 100 to 109. So Q is going to be equal to 112 times 1.996 times 9. So here we're expecting a fairly low number because specific capacity is not very much, and then also our change in temperature is not very high. So 112 times 1.996 times 9, and that would be, let's just call it 3 sig figs again. I don't think that quite works with our change in temperature, but that's okay. Q is going to be equal to 2010 joules, are 2.01 kilojoules. Okay, so now that we're done calculating all these, what do we do with them? Well, the total energy change, which is what we're trying to find, is all of these added up. So we're going to take our 4.21, our 37.4, our 46.9, our 253, and our 201, and add all these up together. So come back up to the top. We have 4.21, plus we have our 37.4, and this is why they have to be all in the same unit. I put them all in kilojoules. You can put them all in joules. Either way works. Plus our 46.9, our 253, and last but not least, our 2.01. And what we get left with is the total change in temperature here, total change in energy. Our E total or Q total, whatever you want to call it, is fine with me, is 344 kilojoules, or if you want to do it in joules, okay, 344,000 joules. Either way, again, works for me. Okay, so that's kind of how we work through these problems. Again, they're not always going to include all 5 steps. It really depends on where you are. I could have you go from 0 degrees Celsius to 101 degrees Celsius. At that point in time, you would just have 1, 2, and 3 steps. You could do all 5 steps. You may only do 1 step. I may ask what it takes to go from 25 degrees Celsius to 90 degrees Celsius. So there's a couple different options that can go on here. So just pay attention and we'll get through these, and they're not too bad. A little time consuming, but not bad. Okay, let's do one more. What I actually want you to do is pause and go through and do this one on your own. See if you can come up with the answer on your own. Okay, and then we'll go over it together. Okay, so let's talk about it. We end up with another one that has 5 steps here. So we're starting down here at negative 9.5, and we're going all the way up here to 121. And of course, we're dealing with water again, based off the fact that we're dealing with an ice cube. So we can assume B to C is at 0 degrees Celsius and D to E is 100 degrees Celsius. Okay, so our first order of business is to kind of figure out how many steps we're doing here. Again, each direction changes a step. So from the negative 9.5 to B is 1 step. B to C is another step. C to D is a 3rd. D to E is a 4th, and then E to 121 is a 5th. So we are dealing with 5 different things here. So almost identical to the problem we just did, except different numbers. So let's just kind of go through this fairly quickly and see how you did. Step 1 is dealing with MCAT. So our Q is going to be equal to mass, which in this case is 25. Oops, I'm not meaning to move that. I'm meaning to grab this. There we go. Is 25.6 grams. Okay, Q equals MC is going to be 2.03, and delta T is our change in temperature, which is 9.5, and that's going to give us a Q, if we go through and calculate this, 25.6 times 2.03 times 9.5, okay, and that's going to give us 494 joules, or again, I convert into kilojoules, 0.494 kilojoules. Okay. From there, we do the next step, which is our delta H of fusion. And I'm going to set it up first off calculating my moles. So 25.6 grams H2O, 18.02 grams per 1 mole. And I'm going to go ahead and continue on and set it up this way. You don't have to do it this way. For every 1 mole, it is 6.02 kilojoules. So 25.6 divided by 18.02, and that multiplied by 6.02, and that's going to give us a total of 8.55 kilojoules. Okay, and that's step 2. Step 3 is going from 0 to 100. So it's our MCAT again. So Q is going to equal 25.6. Specific heat capacity here is 4.18. Jump back up here, we can see that. Okay, and then our change in temperature is 100. So Q is going to equal 25.6 times 4.18 times 100. And 3 sig figs is going to be 10,700. Joules are 10.7 kilojoules. Okay, step 4 is our heat of fusion again. Our heat of vaporization, excuse me. So 25.6 grams. And I'm just redoing this math because I don't actually have that number written down. If you calculated the moles, you don't have to do this again because it's the same mole value. Okay, and then 1 mole is 40.7 kilojoules. And that's going to give us a value of 2.56 divided by 18.02 times 40.7. That's going to give us 57.8 kilojoules. Last step is to go from 100 to 121. Okay, which is using our MCAT again. So Q equals 25.6 times a specific heat capacity of 2.03. Sorry guys, I used the wrong thing because I have them. Nope, that's right, sorry. 1.86. And I'm not sure why the specific heat capacities are different, except I may have pulled them off of the different sheets. But don't stress out too much about that. So 100 to 121 is 21 degrees Celsius. Let me double check that I had that number right. Yeah. Okay, so we get our Q, 25.6 times 1.86 times 21 gives us basically 1,000 joules, which I know is not kilojoules, which is going to be 1.00, or not proper sig figs, but we'll make a proper sig figs converting into kilojoules, 1.00 kilojoules. So again, our total is going to be adding these numbers all up. So we're going to take our 0.494 plus our 8.55 plus 10.7 plus 57.8 plus 1, and we get a total. Uh-oh, it's not letting me write anymore. But either way, a total energy of 78.5. 78.5 is your answer here. Okay? Alright guys, that is as far as I'm wanting to go in this video. You now have a worksheet to work on. Hopefully we are doing okay on this, and if you have questions, just let Mr. Christie or me know. Thanks guys.